Good morning, everybody. My name is Tolga Tarhan. I'm the CTO of Onica, and I wanted to spend a minute today talking about IoT, AR, and all kinds of reality, virtual, mixed, and augmented. It'll be a little bit of a different format than we've normally done. This webinar is going to really be a customer story. So we're going to talk about how we delivered a solution across all these areas and kind of take you through a journey. I'll start by talking about the intent of technology as it comes to sort of workforce management, because we're going to talk about how we leverage all these technologies to improve workforce efficiency. We took a very non-technical workforce, think maintenance type staff, and we went through a transformation with them to build this solution and built up an augmented workforce that actually was more effective, more efficient, and able to deliver better experiences for their customers. Just a quick sort of disclaimer, I am presenting a real customer story, but the details have been obscured, the names have been changed, the exact scenario is a bit different. This is sort of the world that we live in as consulting partners. Often our customers need confidentiality for the work that we do with them. So, my slide will advance here. Let's take this thought experiment, and we're going to build up a scenario with a few slides here. Let's say you have a restaurant, and this restaurant is a single location and has a single dispenser. You can think of this like the iced tea dispensers at most sort of fast food places. It's kind of a big bucket of iced tea, and when it runs low, they brew more tea and add it to the bucket. As a single restaurant with a single dispenser, you've got some options for how you might manage this dispenser. You could station an employee, and they could just stand there all day and fill the thing up as it empties. That would be terribly inefficient. You could have a schedule. Every 15 minutes, someone has a checklist, and on that checklist is check the dispenser. Or you could wait till somebody complains. Now, in the real world, the first and last options aren't realistic. And so really what you end up doing is some kind of scheduled task where people go and check the dispenser at some interval. But what if we scale up? So we're going to do this a couple times in the example. Let's scale up to just a slightly larger restaurant. Now there's 4 drink stations. What do we do now? Do we place a person at each one? Do we have a different person check each of them? Do we check all of them every 15 minutes? And again, at this scale, the answer might be obvious. You would probably still just have a scheduled task every 15 minutes and check these locations, these 4. But it is more complicated, and then it's pretty easy to imagine where this goes when you go to, let's say, a very large property that has a lot of these devices. Something that looks like this. Some kind of, let's take a water park. So these water parks, let's imagine one that has 10,000 of these dispensers. So now, all of a sudden, the idea that you're going to check them every 15 minutes becomes a pretty large logistical challenge. How, if you have 10,000 of these things every 15 minutes, you're checking 666 of them every minute. That's a lot of people to manage these dispensers. So on top of that, we might also have different kinds of staff that need to deal with these. We might have somebody filling them, someone else doing maintenance work on them. We have to kind of deal with the different types of our team that interact with the containers. At the start of our project, our customer's approach was you would start your shift and you get assigned a route, and you would basically work that route all day. You would walk around and fill up the containers that need filling, and when you're done, you take a 5-minute break and you do it again. And so the staffing level needed was pretty much static. It didn't really matter how much was being consumed from the containers. because no matter what, we check them on a fixed schedule. Now, let's give you the last couple details here. These drink carts are portable, and every cart has a different mix of drinks. So not every barrel or container is the same drink as the others. And again, as I mentioned, our workers are following a path. The other thing worth noting is that they will fill these things up even if they're not empty. Because if you're going to bother to walk around this path, you may as well always ensure that they're topped off. Right, here's what it looks like overlaid on our water park. The challenge we were presented with was, can we build a system where the dispensers are never empty, we make as few deliveries as possible, and we use the shortest possible routes? It's a pretty straightforward optimization. Annika came in with our team. We brought in experts in machine learning. We brought in experts in IoT. We brought in experts in cloud infrastructure, and together built a solution to address this customer need. Looking ahead at, at what we built, we worked to optimize the routes, which was the original ask, but we also worked on kind of some extended problems and said, what if we could also optimize where the dispensers are located? And what if we could also help with training, inspection, auditing, sort of the other non-daily operational pieces of the workflow? So we took a three-step approach here. We designed an IoT device. I'm going to talk a lot about that in a few slides. We then built that device and deployed it. And then finally, we implemented sort of XR, and I'll talk about specifically the kinds we used, experiences for that device. So stepping forward now to the design piece. We think of 7 kind of major elements to designing IoT devices. These are the first 4. I'll kind of start with the easy one. Picking a sensor is pretty straightforward. To measure the fill level of a tank, there's all kinds of approaches. It could be floats inside the tank. It could be probably ultrasound or laser. It could be weight. It could be the dispense volume coming out of the spigot. There's a lot of ways to address that problem. Connectivity is more challenging depending on the environment. If battery was never a concern, and if you were in kind of a well-defined location, Wi-Fi is the obvious choice. But as soon as you get into either very long ranges or large outdoor environments or battery, Wi-Fi does become challenging, and you have to look at things like LoRa and other low-power WAN technologies. And then batteries are actually the thing that holds us back the most. Being able to combine the right battery technology, the right size battery with our use case and our transmission needs is probably one of the biggest trade-offs we make in all of these projects. After all that, and then we end up building custom circuitry to support that combination of use case and sensors and batteries and connectivity. These are not generally available off the shelf. We don't find that we can just go to a vendor and say, give me a device that has this connectivity with these sensors, with this battery, with this form factor, with this application. And so when you just think about the permutations of those 4 or 5 factors, you end up with a lot of design, some sort of purpose-built design. And to that end, we almost always end up building custom electronics for these applications. Moving on from that to the cloud side, we look at security and scale as major design considerations. And for security, it's important to note that there's 2 kinds of security that are interesting, at least 2 kinds. There's the security of the data that we're collecting, which is the obvious one. But there's also making sure that our devices don't become compromised and used to attack other infrastructure. So this has happened before with, for example, the Blu-ray players had a vulnerability, and they were used to DDoS DNS infrastructure something like 18 months ago. And that's an example of another type of security surface area that you need to think about. I think one of the biggest things to address security is to ensure you can deliver updates to these devices. And so it was really important in our design to be able to do over-the-air firmware updates so that we could address any sort of zero-day vulnerabilities that were discovered in our components or in components we were using immediately. The scale side is a bit easier with the cloud. We have essentially unlimited storage, so that was easy. And then compute power-wise, we leveraged so many serverless technologies that I'll show you that sort of compute scaling was automatic and simple. So given that design, we built on a platform that we call IoTanium. This is our platform that contains sort of pre-integrated reference architectures. It includes a actual board that's a reference design that we've evolved from real-world projects over the last 4 years. This reference design contains all the sort of heavy lifting: battery, charging circuitry, connectivity with Bluetooth and Wi-Fi and cellular. It has a dual-core ARM processor on it, and it has, in the development form factor, a bunch of different external connectors that we can use to rapidly build solutions by just connecting pieces together. We then take that hardware device and we combine it with a reference design for the cloud components. And so here we're using everything from IoT Core to Kinesis data streams to Kinesis Firehose. We store, in this particular architecture, we store time series data in S3 and then analyze it with big data tools. And we take real-time data through Kinesis streams to Lambda and allow Lambda to do the real-time reactive kind of workflows. So when a beverage container gets low, that can trip off a Lambda that can cause an immediate action. Whereas some of the future predictive stuff we're going to do can be based on analytics we do from the batch data in S3. We also are serving up a web application for this through CloudFront and API Gateway, and again, powered by Lambda. And so in the architecture here, there are no servers of any kind. Then we built a data lake. This data lake houses the resulting sort of aggregate batch data that we collect. And data lakes are complicated. They're more complicated than it immediately appears. Foundationally, it's just S3, but there's all kinds of rules about who, which business unit owns the data, who can access it, how is it accessed, how do we do transformations on it, how do we go from raw data to meaningful business value. And so we built a sort of a reference around that as well. And then, of course, we did take that dev board design that I showed you earlier and eventually build a kind of a bespoke solution and removed those external connectors and produced an actual custom board that was use case specific. From there, we turned our attention to automation. We ensured that all of this could be automated. So the data lake rollout, the deployment of new data lake jobs, the infrastructure itself, all the IoT rules, all this is driven by infrastructure as code. All of it lives in Git. All of it is versioned and code reviewed as if it was software. And the benefit of this model is visibility and control and consistency, and we get it across the whole infrastructure. In some cases, we've even up-leveled this to like service catalog, to where you can launch, say, entire ETL processes from service catalog or entire BI processes. And then we built a dashboard. We realized that when you have 10,000 devices, it was important for our customers' sort of support and maintenance staff to see which devices are online, which devices were offline, why they were offline, when they were last online, what messages have been exchanged with them, kind of troubleshoot these devices. And again, the automation I talked about earlier extended to the entire IoT part as well. All of the IoT components and real-time data flows were represented as code. Forward through this. this is kind of another slice of the way the architecture looks when it's all put together, from sensors to edge devices to the cloud data lakes that are then used to analyze with our analytical processes. Here's an evolution to sort of thinking about your data in a data lake. You have applications. Some of these might be IoT, like I've been talking about, but often you're combining that data with other applications. So it could be for our water park, it could be admissions that day, for example. It could be an interesting data point. We have all this raw data that we then ETL, and that's a data engineering task. And then we build a trusted zone of data that's been properly scrubbed, and we get high value outputs from data scientists working on that data. And of course, this is also where we do AI and ML, and I'll talk about that here next. So SageMaker is a platform that wraps a bunch of components of machine learning into a single service. So starting from training models and being able to distribute the training of models to deploying production inference code, SageMaker kind of has a solution for the whole life cycle. When you first launch SageMaker, you actually get a Jupyter Notebook instance. In this Jupyter Notebook, you're able to begin to play with the data, begin to analyze the data, begin to do tasks that clean the data up. And then you're able to execute SageMaker training jobs, which are distributed across a number of nodes that you can specify, allowing you to do training much more quickly by leveraging a large fleet. Then once you've built your model and stored the resulting artifact on S3, SageMaker can deploy production endpoints that can auto-scale and that can do live inference or batch inference. And so the job of taking your machine learning code and training and being able to deploy that to production with sort of just one extra line of code is a big step forward from the old days of really struggling to move from I have a model to I've deployed a model to production. Here's just a screenshot of Jupyter. Jupyter is kind of a full web-based IDE, very Python-centric in this case. Excuse me. So going back to our use case, let's look at the fill level of these tanks, right? This is sort of an idealized graph here showing you what the fill level could look like over time. Obviously, it's not normally quite this dramatic. But using historical analysis, we could figure out what day of the week or time of day or season or other sort of environmental and calendar factors were driving the utilization of each container. We considered weather, ticket sales, attendance, open and closed venues, other sales of other types of items throughout the property were also considered. We used all that to figure out what was the likely consumption of these beverages. Sorry, just waiting for my slide here. Here we go. And then based on our predictive analytics, we would adjust the next day's routes, and in some cases even adjust the same day's routes. But the main thing here was to predict how much staff we would need for the next day, and to also predict heat maps of utilization and be able to reallocate these beverage carts. Now, as you may know, route optimization is a difficult problem. It's very hard. It's very hard to do after about 15 or so locations, and we have 10,000 of them. So there are algorithmic solutions to the problem, and we employed some of those. And they're essentially approximations that are good enough. And then for optimization, we looked at all these different questions. So, well, I should say we looked at some of these questions, although this is an interesting list of other questions we could have asked as well. So which dispensers have the least in them? What kind of drinks do I deliver? How many carts do we have available? How many workers do we need? What's the volume that each cart can hold? What's the fastest route? How do we maximize our efficiency? These are all sort of interesting questions we could ask. So this is where we deployed some AI, specifically some machine learning models, to sort of try and determine both the optimal routing and assignment, and also predicting the staffing levels that we needed. Moving on now to the sort of reality part of this, or the virtual reality part of this, I want to describe for you 3 different kinds of reality. I guess 4 different kinds of reality. There's actually your real reality, the one you're looking at right now. There's virtual reality, which is kind of fully immersive. You put on like those gaming headsets and you're taken to another world. There's augmented reality, which is when we place objects and information into the scene, but not embedded fully within it. And there's mixed reality, when it looks like the rubber duck in this example actually is inside our room. I think that the second 2 are interesting, particularly. Augmented reality is really great in our use case for being able to take our mobile device and point at one of these containers and figure out what its current fill level is, right? So we could take our phone, point to a beverage dispenser, and overlay a small graph of consumption right on your sort of real-time view. On the other hand, I think mixed reality makes a lot of sense when we look at things like retail and home design and shopping experience, where you could take an item, say on Amazon.com, and imagine if you could place that item in your living room and see what it looks like in place. These are all interesting and all sort of up-and-coming ideas. Consider for a second if you could use this for repairs. So imagine if you could wear a headset that enabled you to see, in this example, this pipe, and understand where the joints are, where the different attachment points are, and maybe even get whatever sensor readings are available from inside the pipe. That enables sort of a more rapid and more productive use of the time to repair, in this case, this pipe. Now, as you think about these different kinds of reality, it's important to consider that this is a big change for the workforce. There's a transformational element here. A lot of people, like take the prior example with the pipe. The plumbers that work on that have been doing that for a long time, and they have a method. And you're disrupting that pretty severely by asking to wear a headset and follow the on-screen diagrams. And so there's definitely a transformation piece that you have to consider alongside this. When we talk about these types of augmented and mixed reality, we have to think about wearables versus mobile devices. In our customer example, a mobile device was sufficient because it was a casual use case where you could hold up your phone and see the fill level of a container and then put your phone away. But in the pipe example that I showed you earlier, you wouldn't be able to do that holding up your phone. You'd have to think about having both your hands free. So there's a lot of trade-offs to consider, and so this slide kind of talks about some of the pros and cons. But the important thing to think about is that you got to consider the device in your design. Amazon has a tool called Sumerian, which can be used to build these experiences. So it's got the design tools and the deployment tools to take and build for Oculus or Android and iOS, and be able to produce these experiences and then be able to update and redeploy them. And so there's a whole toolkit here around this technology. Leaping forward beyond just being able to hold our phone up and see what the fill levels look like. Imagine if we could also give this to the maintenance staff that maintain the dispensers. So here's a hypothetical maintenance scenario for this beverage dispenser. And what if I could look at this either with my phone or with a headset and see sort of the breakout of the parts, as you see here, inside that dispenser. All right, so at the end of the day, we built this customer solution using all serverless technologies. So this was IoT Core, Kinesis Firehose, and data streams, S3, Lambda, DynamoDB, API Gateway, SageMaker, and Sumerian. So none of those require us to run, maintain, or scale any servers. They all scale relatively transparently. They're all fully managed services that we do no sort of undifferentiated heavy lifting for, and we can focus entirely on building business value. At the end of the day, we transformed this workforce. We transformed how they get scheduled, how they go about their day, how they manage and supervise the employees. This is a pretty cool example of sort of a full digital transformation powered by IoT and machine learning and AR. So that's all I've got for you guys today. Thank you for joining. If you've got any questions or would like to chat more, we'd love to converse. Feel free to connect with me on LinkedIn or to reach out to our team and schedule a time to talk.